In reading and math, the words are very important because our brains are smart, but they also trick us sometimes. Our brains get used to patterns, and then we assume something. Okay? In almost every question so far that you've done, if they give you an equation and give you a graph, your brain makes the assumption that they are the same thing. But in this question, they're not. Notice that it says the graph of y equals 1 over negative 2x squared minus 0.5 was reflected in the x-axis, and the image is shown. So this is the image after we've done a reflection. Okay, again, just to practice it. This time they said the x-axis. Is this a vertical or horizontal one? Vertical. Vertical is outside, so this would be y equals negative f of x. Write the equation. You could also set over the line y equals 0. I find the ones that are probably the most helpful is to figure out, is it horizontal or vertical first? Because that, and then once you figured that out, vertical is outside, I know that my negative has to be outside. Okay? So that means the original graph, if I put a blue box around this, the original graph looked like this. And then it was reflected over the x-axis and got the red graph. And the question says, what is the equation of the red graph if this is the equation of the blue graph? And for this, I'll switch to red because I'm writing the equation of the red graph. I think this is the easiest thing to use to figure out the equation. Okay? This means you take the original graph and just multiply by a negative on the outside. So what does that look like? In simplest form, I can put the whole original graph in brackets. There's my whole original graph, and what do I need? I need a negative on the outside. Perfect. Perfect, except I'm going to make this into a multiple choice question. Because you're going to have multiple choice questions on your exam. And since some of you are thinking about going into the AP course, I'm going to make it into an AP multiple choice question, which is like, they sort of up it a level when they get to multiple choice questions. In an AP multiple choice question, they would do the following. They would give you a big capital I, and they might write, for big capital I, they're going to write y equals negative 1 over 2x squared plus 0.5. And then they'll give you an II, and they'll say y equals, and they'll have a negative 1 over negative 2x squared minus 0.5. And then, what color? I haven't used green. And I, and they'll say y equals 1 over 2x squared plus 0.5. And then the multiple choice will look something like this. The answer is 1, 2, and 3. None of the above. 1 and 2 only, 2 and 3 only, 1 and 3 only. Which ones are right, in other words, and which ones are wrong? Or are they all wrong, or are they all right? So I did some algebra, and I took the original answer. The red is correct. If this was a long answer question, and you wrote the red, you would get full marks. That's the right answer. But then the multiple choice went and simplified it and complicated your life. Which of those simplifications are actually right? Which of them are wrong? Or maybe I'm just messing with you and they're all wrong. This is the fun thing about being a teacher. You get to mess with your mind. Oh. All right. So, we're going to do an anonymous survey in a second. If you think something's right, you're going to just put up your hand, okay, with your eyes closed, because that's otherwise it's no longer anonymous, right? We're going to close our eyes. So make a decision. Decide if you like 1, you're going to put up your hand with 1. If you like 2, you're going to put up your hand with 2. If you like 3, you're going to put up your hand with 3. If you think all 3 are wrong, you don't put up your hand at all. If you think all 3 are right, you're going to put up your hand every single time. You can put up your hand as many times as you want. Are we ready? Made some decisions? Got feeling? Close your eyes. All right. On the black one. Hands up if you like that one. Okay? On the second one, hands up if you like that one. All right. And on the third one, hands up if you like that one. All right. Okay. Eyes open. I was thinking, we kind of destroy the purpose. And while I asked the first question, I was like, Jesse, do you have a question? You have your hand up. Oh, sorry. All right. So, this is good because what you're going to find out is that lots of you have a little mental math problem in this question. Because the survey went as follows. The most people thought the black one was right. The black one is wrong. Only one person thought the orange one was right. The orange one is actually, it is right. And a few more people thought the green one was right. And the green one is also right. So why are those 2 right and not the other one if this was multiple choice? What happened mental math-wise? And what little tiny math rule are you getting mixed up with another little tiny math rule? Because this is really a little tiny math rule mix-up. The mistake that you made if you chose the black one is you took the negative and you distributed it to everything. Because you're used to distributing numbers in front. But how do we distribute numbers in front? Usually that's when we have 2 separate things, like x plus 3, then the negative would go to both of them. This is a fraction. So we have to think, what are our rules for multiplying fractions? Right? You need to multiply the top and multiply the bottom. And if I have a -1 out in front and I wanted to write that as a fraction, I could write it -1 over 1. Or I could write it 1 over -1. But I cannot write it -1 over -1 because then it would be positive. So if you did the complete distribution, the top and the bottom, you were actually multiplying by a -1 on the top and a -1 on the bottom, which makes it positive. So we can see that the orange one is right if you thought of having the -1 on the top. That would keep the bottom the same and change the top to a negative, making the orange one correct. Or if you put the negative on the bottom, that would keep the top the same, and on the bottom you would have to distribute here. When you multiply on the bottom, change everything to positive. So this is an example of how the AP will ask you a question. You're able to do part of it, but they're like, we just want to make sure the rest of your algebra skills are up to date and ready to go. So we'll check some other things while we're at it. And if something's not up to date, then you're going to get that question wrong. Which makes them a little bit more tricky and more challenging. But for those of you taking that course next year, we get lots of practice with that. But the thing about the practice is it's like, oh, that was a good review of some basic math skills that it's easy to make a mistake with. Okay, so I better reread the question. Yes. I don't have to do domain and range. Anybody else getting a little bit tired of always doing that? Questions for practice on this one? 7, 8, 9, and 12. And 12, okay. I'd like you to put a star beside number 12, and maybe PS for problem solving. One of the outcomes of this year is to get you to be better at problem solving. What a problem solving question looks like is it often connects things that you've learned in the past to things that you are learning right now in a situation you've never seen before. So you have or should have the tools to figure it out, but it won't be like a question that you're like, oh, I've done one like this, I just have to do this to get it. Okay? So on every test that we have a small section that will be problem-solving questions, where you have something just a little bit different and new, and you have to develop your skills and what you know to be able to solve it. Okay? I'm not doing problem-solving questions to be mean, right? They're harder, right? And usually when teachers get, like, I haven't seen this before, that's mean. I'm not doing it to be mean, but I am doing it because we need to get ready for our provincial exam. I don't write your provincial exam. Somebody else has already written it. There could be questions on the exam that are worded a little bit different than I do them, or sound a little bit different. And if you go into the AB course, there's a ton of them. That's what they like strive to like come up with a creative way of asking the same question. So we need to develop our skills to be able to do those questions. So number 12, try it. For tomorrow, we'll go over it at the beginning of class tomorrow and talk about some of those problem-solving skills that we can develop. Okay? But I do want you to like take a step, see what you can come up with on your own. Connect it to things that you've previously learned. Again, I'm not doing those questions to be mean or to trick you. I'm getting you to be able to, everything on that exam, you're going to be able to do. But sometimes we have to go back and sort of use some problem-solving skills to get them. So that's what we're going to also be developing this year.